Welcome back to my channel. Sweet Tips here. And what we're going to be doing today, I've got some pieces of gold down here that I've got from some previous videos. This piece is from the filter papers, first extraction. This little piece down here is from the second extraction. This is a piece of pure gold that I got out of some cellophane foil wrap that was coated with pure gold. And this piece here is some gold that I recovered out of my temporary storage bottles out there where I pour off my gold refining waste. And I dissolved the gold out of the bottom of those and got this big button. Plus I have one more bottle out there of waste that I've been saving. We'll precipitate the gold out of that. And then I'm going to add it all together into one melt dish. We're going to pour it into some water to make some shot. I'm going to get a weight on these buttons of gold that I've got here. Looks like we got 25.4 grams of recovered gold in these buttons. All right, let's take this out. And what we'll do now is go out here and we're gonna recover some more gold out of a solution that I have out here. This is a solution that I've been saving when I get small quantities of gold in solution. I would pour them into a bottle, and I've poured the contents of that bottle into this beaker, allowed the solids to settle out. I'm going to turn my vacuum pump on now, and I've got my vacuum bottle set up down here. And we're going to draw the liquid out of this container into this flask, and then we're going to precipitate it with sodium metabisulfite. Here we go. The solution in that beaker came from solids that settled out in my waste containers. I gathered it up, dissolved it, and then put it in that beaker. All right, now what we'll do is transfer that solution into this beaker here, and then we'll precipitate the pure gold out of this solution with sodium metabisulfite. Sulfite here. This is a waste solution that I've dissolved the pure gold from it. It's kept it, and now what we're going to do, we're going to dump some sodium metabisulfite in here and precipitate out the pure gold. Real-time video here. You're watching it precipitate out in real time. Filter the solids out of this. It's going to be our gold. Someone asked me, how do I choose whether or not I'm going to use vacuum filtration or gravity filtration? And generally speaking, if I'm going to be filtering out the solids out of a waste solution, and I want to keep the solids and get rid of the waste solution, then I'll end up using a gravity filtration, like we're doing here. I've got solids in this beaker back here. I want to get those solids out of that solution, so I'll gravity feed it through a filter paper. If I had gold in solution with trash in that solution, and I wanted to remove the trash from the solution, what I would do then is use vacuum filtration with a Buckner funnel. So I hope that answers that question. What we're going to do now is put this filter into our funnel up here. I'm going to wet it down a little bit. And now what we'll do is we'll filter out our solids down into this filter paper and collect them up and melt it into a button. Get the rest of this gold in this filter now. You can see brown gold down in the bottom of the beaker there. Not all that much of it. Here's that little bit of gold that we precipitated out of that waste solution. So now what I'm going to do is I'm going to get a melt dish up here, and we'll put this little bit of gold in this melt dish. I'm not going to put all that paper in there though. What I'm going to do, rip off this much. It's got most of the gold in it right there. And then this is going to go into our paper storage. And now what I'll do is I'll add the 25.4 grams here to this. I'm going to take this over, put it on the melt table, and get it melting. This footage is speeded up 8 times normal speed. I bought a new welder's helmet with a new visor so that we could eliminate those scuff marks that were in the old visor and get a better view when we do these melts. If you notice on the side of that melt dish, you'll see a hairline crack. I didn't notice it until after I got done doing the pour. You should never use a cracked melt dish, because what could happen is the molten gold could come flying out of that thing, bounce all over the hard surfaces, and make a million tiny balls of gold that spread all over the floor. Here's our gold, nice and dried off. I got the scale set to 0 here. We started out with 25.4 grams. We added that little bit that we just precipitated. Now we've got 26.1. 26.1 minus 25.4 equals, so there was 0.7 grams in that solution that we recovered. We've got 26.1 grams of pure gold here. I'm going to inquart it with silver. To do that, we take 26.1, multiply it by 3. That will give us 78.3 grams of silver that needs to be added to this to make an alloy of 25% gold. But I want to reduce the amount of silver so that we get about a 26 or 27% alloy. So I'm going to multiply 78.3 times 0.95. We get 74.3 grams. I've got some silver here already pre-weighed. What I'm doing is we're going to use 74 grams, rounded down from 74.3. Here we go. We're going to alloy this gold with the silver. I can hear what you're thinking. Why is he adding silver to that gold to purify it? There's 3 reasons. Number 1, this is a refining technique called inquartation, where we make an alloy that is 1/4 gold and 3/4 sterling silver. Reason number 2, that gold was not high purity gold, and adding silver to the gold, like I'm doing right here, and then parting it out with hot dilute nitric acid does a fantastic job of removing impurities. And reason number 3, I refine silver also. The first step in that process is to dissolve the silver in hot dilute nitric acid. So why not use the silver to purify the gold? I'm killing 2 birds with 1 stone. Over the years, I've developed a technique for stirring this metal to achieve a good alloy. And what I do is I stir that metal, and when I think I've stirred it enough, I stir it for about another 20 or 30 seconds before I pour the metal into the water. Now that this gold has been alloyed with that sterling silver, the hot dilute nitric acid treatments in the next step will be able to penetrate to the very core of each piece of that inquarted gold. Okay, here's the gold in our metal can here. I'm going to pour the water off. I'm going to pour the metal down into this glass container here. Now we're going to pour out the tap water out of this glass container here. We're going to rinse the gold a couple of times with some distilled water here. And that's in order to rinse off the tap water. It'll have chlorine in it because the next step that we're going to do is use nitric acid to dissolve out the silver in the base metals. If we leave chlorinated tap water on this metal, it will react with the silver nitrate, form silver chloride, and cause problems for us when we go to filter. Okay, here's our metal. Here's the inquarted gold in this beaker. I've got some used dilute nitric acid from a previous refining. We're going to add some of that to our inquarted gold now and start removing the silver and the base metals out of the inquarted gold. time-lapse footage here. What's happening now that we have the gold alloyed down to about 26 or 27% with that silver, the nitric acid can penetrate to the core of each piece, forming a honeycomb structure as it goes to get 100% of the silver and base metals out of that gold. This has been on here now for about 45 minutes on the heat. That was our first hot dilute nitric acid boil. What we'll do now is take this, I'm going to pour this off into a container down here. This liquid will have silver in it, so I want to save it. Someone asked why I rinse the gold off real good here, and I want you to look at the beaker after I get done pouring. You'll see in there, as soon as the solution kind of evaporates away, you'll see some silver starting to form, silver nitrate crystals starting to form inside there, and that's why I rinse this out real good, to get that silver out of there. What I'll do is add some more dilute nitric acid here. Going to continue. This will be nitric acid boil number 2. Nitric boil number 2 has been going for about 45 minutes. I'm getting ready to pour that off. But before I do, I want you to notice this green solution down here. Dipped a piece of filter paper in there. What we're going to do is put some stannous chloride testing solution on here and test for the presence of precious metals in that solution. We'll just give it a minute here. You can see I'm starting to get a reaction on the filter paper from the stannous test. I've got a significant brown color, which tells me that I've got some precious metals, probably platinum group metals, in my silver solution here. What I'll do is I'll add some more silver to this to consume the excess nitric. And when there's a few pieces of silver left in here, so that I can confirm that all the nitric has been used, I'll filter out all the solids, and then I'll cement this solution. I'll cement the precious metals and the silver out with copper, melt it into shot, run it through my silver cell, and collect the precious metals in the anode filters of the silver cell. Okay, now we're going to get the second nitric boil off of here. Pour it into our silver container. Notice how light the solution is. It means all the silver and the base metals are being extracted with these nitric acid boils. Gold is holding together nicely. There's a nice brown color. Put another shot of nitric acid in here now, and this will be nitric acid boil number 3. But paying attention when I poured that silver solution off into this jar. Some of the gold got poured over with it. That's okay. I'm just going to leave it in there. And I'll recover that later on when I filter the silver solution out. That's what you get for trying to operate a camera and refine precious metals at the same time. The third nitric boil back here is complete. I can tell there's no fumes in here. The solution is still staying nice and clear. So what I'm going to do now is I've got some silver here. I'm going to burn this silver, add it to this jar right here. That silver will consume the additional nitric acid that's left in here. What we're going to do is take this third nitric boil, add that to our silver jar. There'll be a reaction here. See, the acid immediately attacks silver. Distilled water here. We're going to do a final nitric acid boil. This is fresh reagent. Fresh nitric acid going in here. And we'll just let this boil one more time just to make sure that we've got all the base metals, all the silver, and any platinum group metals out of our gold. Our fourth nitric boil, it's got a nice rolling boil going on in there. The solution is crystal clear, no color, and there's no fumes being produced. That tells me that all the base metals, platinum group metals, and silver have been removed from the gold. So now what we're going to do, we've got a bottle here labeled used nitric, and I'm going to transfer the nitric solution that's in our beaker here into this container, because it will still have good active nitric acid that can be used to dissolve silver and base metals in a future video. The nitric out of there. What I'll do is set this aside, and I'm going to rinse our beaker out that's got our gold in it. I'll pour those rinses off into my silver jar back here. Silver's gone now, so I can add some hydrochloric acid to this. We'll make some aqua regia in here, adding muriatic acid, another name for hydrochloric acid. I'm going to add about 100 milliliters here, or maybe 200 milliliters. Sulfuric acid in. This will precipitate out any lead that might be present in here. Cover this up now. I'm going to put it up on the heat and begin dissolving the gold out of that solution. A little bit of concentrated nitric we'll get the pieces of gold to dissolve. That was about 12 milliliters of concentrated nitric acid. We'll let this go and let this dissolve now. That took about 10 minutes. We've got everything go into solution. There's nothing left solid in the beaker there. So what we'll do now is take it down off the heat, let it cool down, and then we'll filter. I'm going to add a few ice cubes to our solution here, get it cooled off. Set up a filter flask here. Got a little Buckner funnel. It's got little holes on the bottom of the funnel there. Got a ½ liter flask. There's a rubber seal between the funnel and the flask. We'll connect the vacuum to it now. We're going to put in filter paper here. Number 3, slow flow. I'm going to add some water to get it to seal up. Then we're going to pour our cooled solution off to the flask, to the filter. Filtering is complete. You can see I got a little bit of junk down in the filter there. Not much. I'm going to rinse the color out of here now. Transferred the solution into a clean beaker. Now we're going to add some sodium metabisulfite here. Precipitate out the pure gold. Here we go. This is the cool part. This is the part I like doing right here. There we got some foam going. That should be enough. The gold to settle out overnight. As you can see, the solution's nice and clear. We got our nice brown gold powder down at the bottom. Now what we're going to do is I'm going to pour off this waste solution into a temporary waste container here. Excess sodium metabisulfite out of the gold powder. And then what we'll do is pour this off into our temporary waste container here. Add a little bit more and do the second rinse here. Just trying to rinse the excess sodium metabisulfite off of our gold. There's a little bit of gold suspended in this rinse, but that's okay. It's going into our temporary container, and we'll recover that later on. Rinse this with a little distilled water now. One quick rinse. Second refining on this. I'm planning on keeping this as part of my own personal stock here. So I'm not going to double refine this. I'm just going to go ahead and I'm going to get this into a melt dish now. Get into my waste container. Let's move this over to the melt table now, and we'll put some flamage on it and get this melt started. Alrighty, in this footage here, I was kind of confused as to what move I was going to make next. I was going to rearrange things and try to melt that button back into molten state and then pour a bar, but I got to looking at the button and it was so beautiful looking that I decided to abandon the idea of remelting and trying to pour it into a bar and just go ahead and get it out of that dish. Look at that thing, man. That thing's just gorgeous. And so I just went ahead and pried it out of there with some tweezers and got it cooled off and decided to keep the button just like it is. Here is our pure gold button. It's absolutely stunning. It's got a little bit of contamination on the surface there because I didn't double refine it this time. And probably 995 on this button. But it's got a mirror finish. You can see yourself in it, which is pretty cool. The pattern on there makes it look like a picture of a globe or something. I was going to pour it into a bar, but then I looked down in the melt dish and seen that thing sitting in there. I said, you know what, that thing is gorgeous. I'm going to take it out of there and just leave it like it is. So let's get a weight on this thing, see what we got here. 24.7 grams of 995 pure gold. That'll wrap this one up. I got a button here. 24.7 grams. I tried to stamp my name on it there just for the practice, and I messed it up again. Made a double strike. That's okay. I'm going to keep this one. This one's about 995 purity. There's a little bit of discoloration on the surface. You can see it there. The original buttons had some platinum group metals in them, and I think I got pretty much all that out. But if I refine this a second time, I could get it up to 3 9s. But now I made the video anyway. I'm gonna keep this button for myself, and I got some more videos coming up. I think the next one I'm gonna do is the silver cell filters, and we'll get that one rolling for you right away. And that'll do it. That'll conclude the video. Thanks for watching.